Thank you. Thank you very much, Madam Chairperson. Can you hear me?
Yes, sir. Yes, we are.
Right, that's good. All right, let's hold on. I'll just try to share my screen. Okay, can you see the screen now? Just making sure before I start my presentation.
Yes, we can see.
All right, that's great. Okay, thank you very much again. Good afternoon. Thank you for inviting me to make my presentation. Okay, the title of my presentation is on the adoption of the Sustainable Development Goal, okay, and industry-oriented curriculum in higher education engineering program. So first of all, let me quickly introduce myself. My name is Hasril. Currently, I am the Deputy Dean for the Academic and International at the College of Engineering, Universiti Tenaga Nasional in Malaysia. I'm also the Associate Director for Mechanical Engineering. My background is mechanical, by the way, with the Engineering Accreditation Council, the Board of Engineers Malaysia. So today I'll try to share with you on the adoption of this SDG into the engineering curriculum. Okay, to be fair, there is no specific method or specific way on how we can do this. This is also in line with our latest IEA paper back in 2001, and then we have a new sets of outcomes that we need to fulfill. Okay, so the outline of my presentation today is as follows. First of all, we go quickly on the overview of the knowledge profiles, okay, and also graduate attributes as stipulated in the paper, and what are typical or common strategies that we can use for the implementation. Okay, and then on the implementation side, they will go through some of the example that I can share with my institution, especially for the mechanical engineering program for bachelor's level program. Okay, probably a good example is to show some kind of integration into the integrated design project, as well as the final year project. And then my presentation will end with some issues and challenges which I think might worth be sharing with all the participants today. Right, this is the new sets of knowledge profiles that we can see from the paper, the IEA paper version 4, okay, back in 2021. So as you can see, and there's not much changes as compared to the previous one. Okay, and then we are concerned about the knowledge profile on the role of engineer in society, which is under the WK 7. And then probably it is also worth mentioning that under the new knowledge profile, we have a new inclusion of ethics or inclusive behavior and also conduct as an addition to the knowledge profile to be included in our engineering curriculum. Right, so talking about the SDG or Sustainable Development Goal, and then looking at the expectation on the graduate attributes that we want to embed into engineering curriculum. So this is some of the keywords that I use, okay, to represent the graduate attributes or program outcomes starting from PO number 1 until PO number 11. I think probably most of you are already familiar with the expectation. So we start with the knowledge on the PO number 1 or graduate attribute number 1. Okay, followed by the ability for our graduates to solve complex engineering problem, or I just put it there as a problem analysis here. Right, and then design or development of solution. okay, as PO number 3, and then our graduates are also expected to be able to do some kind of investigation or analysis. Okay, and then we have the tool usage. Then we have the engineers and the world, which is under PO number 6. Okay, ethics as part of the PO7, individual and collaborative teamwork. Okay, we have communication, project management, and finance. And last but not least is on the lifelong learning. So as you can see here, okay, out of these 11 outcomes expected from our graduates, specifically if you refer to the paper, we have this problem analysis and also the engineers and the world, which is tied up with our sustainable development, okay, the SDG. So in other words, by the time the students graduate, we anticipate or we expect our graduate or our student is able to relate on the problem that is being solved, okay, part of the complex engineering problem with some kind of the SDGs, okay, based on PO number 2. And on top of that, we also expect them to relate the UN SDG with the engineers and the work. So this is clearly mentioned inside the IEA paper, or shall I say the new standard expected from our engineering graduates. So the question is, how are we going to make sure that in terms of our delivery, in terms of our assessment, we are able to at least train the student or test the student, okay, as long as they are able to relate PO number 2, which is on the problem analysis here, and also PO number 6, which is on the engineer and the world with the SDGs, or with any, probably not all, but some or more than one of the listed SDG, whichever is suitable according to their program. Okay, if you look at the PO number 2 on the problem analysis, okay, the wording mentioned is that they should be able to identify, formulate research literature, and analyze complex engineering problem, reaching to substantiated conclusions using the first principle of mathematics, natural sciences, and engineering sciences, with holistic consideration for sustainable development. Okay, so this is the wording that is listed there. So as a program owner or to deliver the teaching and learning as well as to do the assessment, this is something that we have to consider. Similarly to PO number 6 on the engineer and the world, this is fairly straightforward as the name implies. When we teach student engineer and society as an example, automatically we have to make sure that they understand in terms of the concept of sustainable development impact to the society, to the economy, sustainability, health and safety, legal frameworks, and also the environment. Okay, this is part of and parcel of consideration that needs to be taken into account for complex engineering problem. Right. In terms of the strategy, there are, as I mentioned, there is no right or wrong solution, okay, to how the institution can adopt the implementation of SDG into the curriculum. Either you can say probably it is a top-down approach, or you can also say that it should be done in the bottom-up approach, or probably it is also based on hybrid or both approach. So you can have a university-wide policy here. So this is generally coming from the top, involvement of the university-wide sustainable development policy. Maybe some of the institutions are already having some kind of established policy, okay, on the sustainable development. So if that is the case, I believe the implementation of this into the curriculum will be much, much easier as compared to those without any. Okay, and then probably it is also better to start with an inter-faculty engagement, right? Cross-faculty engagement for teaching students to encourage interdepartmental working. Okay, bear in mind, that we have all the 17 SDGs are all together. Okay, not necessarily all has to be covered by engineering graduates. Social science play a crucial part in addressing maybe some of the element of the SDG. So as what have been explained by our previous speakers before, it has to be collaborative working between the engineering fraternity as well as the social science side as well. Okay, and then on the implementation, it is the implementation side where we have to integrate all this into the curriculum through either parallel, top-down, and also bottom-up approaches. And most importantly, okay, all our teaching staff members or academic staff member has to be aware the importance of us, okay, to disseminate this information because they are the frontliners. They are the one responsible to deliver the teaching and learning and also to do the assessment. So it has to come together as a team. Okay, they have to be aware in terms of what needs to be done, okay, for the adoption of this SDG into the curriculum. Right, for the implementation or integration of SDG into the curriculum, right, through parallel top-down and bottom-up approach can be divided into three. You have to start with the awareness. This is very, very important, right? Probably some workshop would be good give to set the scene so that all the members of the academic staff are aware. It depends on what are the nature of the subject or the courses that they are teaching. And then as the head of program, okay, we have to identify the courses, whether it is an existing courses, whether it is worth to start a new course or a new subject that is suitable to probably cover some of the elements. So as we can see here, for engineering, there is fairly straightforward. It depends on the field. You have civil, mechanical, electrical, chemical, and you name it. We have so many different fields altogether. And out of these courses, there are some core courses, elective courses, design courses, projects, or probably lab-based courses. I think for engineering part, it is fairly straightforward. You can simply map to any of the elements that we have in the SDG, the 17 SDGs altogether. I think mapping is one thing, but most importantly is how the teachers or the lecturers want to relate any of the elements to the actual content in terms of the fundamental. Okay, and then we must ensure that in order to integrate this element of SDG into the courses or into the subject, okay, we don't want to lose the most important fundamental of each of the core courses. This is something that we must always bear in mind. Okay, on top of that, I believe the program or the engineering program should also have some kind of some social sciences subject being taught to the student. And this is also important for us to cover some of the so-called element which is not directly related to the engineering. Okay, once we identify the courses, and then it is also good to have developed syllabus to be starting from scratch, or the existing syllabus to be modified so that we can include the element accordingly. So in terms of the content, whether you want to introduce a new topics or whether you want to completely introduce a new course. And of course, teaching and delivery is one thing. In order to ensure that student is actually getting the knowledge, they have to be supplemented with some kind of assessment. It does not matter what kind of assessment, either it is in the exam or projects or design report or dissertation or any other sort of assessment. I think even though it looks fairly straightforward, in order for us to make sure that these are actually being integrated into the curriculum, and student gain the maximum benefit of it, it has to be done by design. Okay? It cannot be done coincidentally. The program owner has to have to design it properly, okay, in order for the dissemination of knowledge to be smooth to the student. Some literatures or some findings, this is from maybe some of the papers in 2020 and by Engineers Island. If you can see here, these are an example of surveys done, okay, to the academics and to the employer in terms of what are the elements, okay, importance according to the engineering. If you can see here, we know that we have 17 SDGs altogether, okay, but somehow, probably I would say like affordable and clean energy, clean water and sanitation, climate action, sustainable city and communities are very much or easily integrated into the engineering curriculum compared to the others. But then again, if you look at another surveys done under NUI Galway's present coverage of SDG in engineering curriculum or engineering program, this is by Engineers Island as well. So you can see that the coverage of SDG varies depending on the nature of the program. Okay, for example, let's say this is an energy system. So these are different kind of SDG that is, that is able to be covered compared to probably civil, biomedical, mechanical, or electronics and electrical engineering. Okay, I think what is important, it is not possible or impossible for a specific engineering program to completely covers all the 17 SDG, but somehow our graduates needs to be reminded on the importance of all the 17 SDG, even though maybe some of them are less covered as compared to the other program. Okay, this is an example for the mechanical engineering program. So you have year 1, year 2, year 3, and year 4. You have different courses covering year 1, year 2, year 3, and year 4. And then from there, the plan has to be mapped according to the nature of the courses, right? So as in this example, year 1 and year 2, we have completely different nature of courses or subject, which is mapped to probably maybe a few of the elements of the SDG. I think this is a good step or a good first step for us to have some idea in terms of what are the elements that can be embedded into the courses. Okay, this is for year 3 and year 4. You have some of the element, okay, being mapped into the courses. And then from there, you can start designing the curriculum or designing the assessment suitable for the coverage or at least to the, for the exposure among the student. This is an example. The easiest is for us to embed this into either capstone design or integrated design project. This is an example of an integrated design project. We give this kind of problem, okay, to the student when they are in the final year. Okay, the title of the project is Design and Development of Cleaning System for Floating and Submersible Object for Turbine Intake in Remote Areas. So the implementation wise, this is, we bring the student to the site, we make some kind of evaluation, and then when we come back to the university, the student will have to come up with a proper design, okay, on solving any of the issue that we mentioned. So in this case, this looks very, very straightforward for them to start linking this to any of the SDG element. So we can also integrate this into the proper design process. Okay, and towards the end, they should have come up with the final design. Similarly, for final year project as an example, we have this problem on the investigation of the combustion behavior of ammonia as fuel blend in the gas turbine combustor. So in this case, instead of using the conventional fuel, which produces a lot of CO2 as an example, right? We try to look at the potential of having a different kind of fuel that does not emit any CO2. So technicality of it falls under the combustion kinetics or chemistry. But in terms of the application, we want the student to understand why this is important, right? And then what benefit it will give to the community at large. Okay, and then we can have many other possible example for the integration of this SDG. So throughout the process, let's say for final year projects, students start with the literatures, then they develop their methodologies until they solve the problem. We can always tie that up with any of the element of SDG. So at the end of the day, when the student is drafting the report or drafting the thesis, we want them to understand that each of the step needs to be referred to the importance of any of the SDG element. This is just one of the many examples. Right. My final slide shows some of the issues and challenges based on the experience implementing this SDG throughout the curriculum. The first thing is that SDG are definitely, I mean, the element are program dependent, and then you would anticipate or you would expect there are low coverage of some SDGs, which is practically fine. Okay, it is not possible for us to cover all, but for the student, for the engineering graduates, we want them to appreciate that. Okay, and then it requires full cooperation for course owner from different faculty. It is a cross-disciplinary, probably for social science, who teach in engineering program. Okay, they should be able to cover the element which is not really directly related to engineering. Okay, something that we have to pay attention is that in the process of doing this integration, there is also a tendency for us to focus too much on SDG, which is also not good. Okay, as member that the main objective is for us to disseminate the most important fundamental of engineering, core fundamental for different field. So we don't want this to be diluted by focusing very much on this SDG. So there must be some kind of balance. So there are also tendency for us to increase student learning time or student focus shifting towards doing proper study or proper analysis on engineering towards focusing on this SDG. Okay, as I mentioned just now, finally, the cost and assessment needs to be carefully designed and implemented. It has to be done by design, cannot be by coincident, right? So it has to be integrated together with the specific course learning outcome and also very, very explicit assessment on the related SDG. All right, so basically, that is my sharing of presentation in terms of how we adopt or implement this sustainable development goal into our engineering curriculum. Thank you very much.